Hello everyone, this is video 7 in the College Algebra series, and today I'll be talking about applications of linear equations and modeling. This is going to be the new topic, and I think I'll go over it for a couple of more videos. And today I specifically will be talking about the applications of the point-slope form. Okay, let us begin. So the slope formula can be used to develop the point-slope form of a line. If you recollect, m, which is our slope, is y2 minus y1 over x2 minus x1, which is essentially rise over run or change in y divided by the change in x. Now, when we multiply both sides by the denominator, we get this equation, which is the point-slope form. So what we essentially are doing here is we have this as our slope, right? And then we are multiplying both sides by the denominator. You get this. And now you can cancel these and you end up with this equation, which is here, which is called the point-slope form. So for a point-slope form, all you need is your m, which is the slope, and either 2 points if the m is not given, or just 1 point to get our line equation. Okay, I have 3 problems to do today. 2 of them are the same kind of problems, and 1 is a little different. This is just to understand point-slope form a little more intuitive way, and understand how we can generate our line equations when we are given some information. Okay, so the first question here we have is find the equation of the line that is passing through 2, -3 and has a slope of -4. So here we are given a m, which is our slope, is -4, and we are given x1, y1 as 2, -3. So we are given a point and the slope. If you've watched the previous videos in this series, you know that to get a equation of the line, a point and the slope is enough. In the last video, we used the equation y equals mx plus b, where we had to find our intercept, which is 0, b, and we used m and a point. Here we'll be doing something similar, but now we'll be using the point-slope form instead of the slope-intercept form. All right, so our point-slope form is y2 minus y1 equals m times x2 minus x1. So instead of y2 and x2, I'll just plug in y and x, because now we are looking for an equation and not a value. And I'll write the rest of it the way it was. Now here we already have the value for m and x1 and y1. All we need to do here is plug in the values. So instead of m here, we have -4. And instead of x1 here, we have -2. And instead of y1 here, we have +3. And y plus 3 equals -4 times y minus x minus 2. Okay, now let us expand stuff and try to write it in a more concise way. So we have y plus 3 equals -4x plus 8. So y equals -4 plus 8 minus 3. All we are doing is subtracting 3 on both sides here. So we get y equals negative 4x plus 5. This is our equation of the line which passes through 2 comma negative 3 and has a slope of negative 4. So once you solve this problem, if you want to know, is this the right answer, there is a form of verification where you just plug in back this point that we have and make sure we get our left-hand side being equal to the right-hand side. So before that, one thing you can instantly see is our slope is negative 4, and we also see the negative 4 here because this equation is written in the form y equals mx plus b. We see that m is negative 4 and we are given that m is negative 4. So we at least know that our answer is partially correct by now, and to make ourselves 100% more confident about our answer, let us do another layer of verification, which is just plugging in our x and y values and seeing if the left-hand side equals the right-hand side. So here I'm going to use the point 2 comma negative 3 here. So 2 is going to be my x and negative 3 is going to be my y. And we will plug it in to this equation. So y here is negative 3 and x here is 2. So I have negative 3 equals negative 4 times 2 plus 5. So that would give us negative 8 plus 5, which is negative 3. So we get negative 3 equals negative 3, which is a true statement, which just proves that our equation that we found here is the equation of the line that passes through this point and has a slope negative 4. All right, let us do another problem. So here we are finding the equation of the line that is passing through 2 points. As you can see here, the difference between the previous problem here and this one is in this one, we are given slope and a point, and here we are given 2 points and there is no slope involved. So how do we get the slope? Because if you recollect, our point slope form, which is y2 minus y1 equals m times x2 minus x1, we need m. So if we want m, let us try to find m by just dividing both sides by x2 minus x1. So you get y2 minus y1 divided by x2 minus x1 equals m, which is our slope formula. And now here we have 2 points. So we have x1 comma y1 as 6 comma 2 and x2 comma y2 as negative 3 comma 1. So now let us plug it in here. Instead of y2 you have 1. Instead of y1 you have 2. Instead of x2 you have negative 3. And instead of x1 you have negative 6. Then you get m equals negative 1 by negative 9, which is 1 by 9. So now we have m as 1 by 9. Now we can just continue the same steps that we have followed before, where now we have an m and we have 2 points. So good thing is now we have a choice of which point we want to carry forward to find our equation. And one thing to remember is no matter which point you choose, either 6 comma 2 or negative 3 comma 1, you'll end up with the same equation. I will solve it using both the points just to show you that no matter which point you choose, you would get the same answer. This is mainly because these 2 points are kind of hidden in our m because we're trying to find the slope, and we know that once we know the slope, we will essentially know all the points which this line is going to pass through once we know a point. Okay, so let us find our equation of the line using the first point. So I will use 6 comma 2 first. Plugging it into our equation here instead of, okay, let me call this x1 comma y1 as 6 comma 2 and plug it in into this equation where we will again take y2 and x2 as y and x. So it's going to be y, that's going to be x. y1 here is 2 and m we found out is 1 by 9. and x1 is 6. So you get y minus 2 equals 1 by 9x minus 2 by 3. Get y equals 1 by 9x minus 2 by 3 plus 2. Get y equals 1 by 9x plus 4 by 3. That is your equation when you choose your point as 6, 2. Now let us find out if we use the other point here, if we use x1, y1 as negative 3, 1, will we get the same answer? I will start it here, writing down the points of formula again. So here I have y2 minus y1 equals m times x2 minus x1. M is still 1 by 9. X1 is negative 3. It becomes positive 3 because we have a negative here. And y2 minus y1 is 1. So we have, instead of y2, let us call this just y and x. So y equals 1 by 9x plus 1 by 3 minus 1. Not minus 1, plus 1, because we are adding 1 on both sides here. So here we are adding 1 on both sides. And you get y equals 1 by 9x plus 4 by 3. So that is our equation, which passes through negative 3, 1 and has the slope of 1 by 9. If you see closely, we get the same answer for both the points. So this is proof that no matter which point you choose, you'll still end up with the same answer. So if you have a point which has smaller numbers, maybe it's easier to manipulate. So if, for example, if I was given some number that says like 60, 30, it's pretty easy to use 6, 2 instead of a much bigger number. We can also verify this again using these points just to make sure, though we got some sort of a verification here showing that both the solutions are the same using different points. It's just another layer of confirmation where we know for sure that our answer is correct. So we will just plug in. I'll just plug in into one of the equations, which is more than enough to say that it's true for all points. So here we have y equals 1 by 9x plus 4 by 3. So let me plug in 6, 2 here. So y is 2 and x is 6. So you get this, which is 2 by 3 plus 4 by 3, which is 6 by 3. You get 2. So you see that we get 2 equals 2 here, which is a true statement again, which verifies that our answer is correct. All right, let us do one last problem here. It is similar to the last one, but this has a bunch of negatives. It's very important to be careful when you have a lot of negative signs, especially because our formulas also have negative signs. So there is a higher possibility of getting things slightly wrong, slightly miscalculated when you have a bunch of negatives and a few positives. Okay, so let us do this slowly, step by step. And for this one, I'll choose only one point to get my equation, since we've already seen that no matter which point we choose, we get the same one. So it's just quicker and easier, and we will verify this as well. All right. So our points of formula is y2 minus y1 equals m times x2 minus x1. Dividing x2 minus x1 on both sides, we get our slope formula, which is y2 minus y1 over x2 minus x1. So this is going to be our x1 comma y1, and this is going to be our x2 comma y2. So now here we have y2 as negative 2 and y1 as negative of negative 1 and x2 as negative 8, and then we have x1 as negative 6. So we have negative 2 plus 1 divided by negative 8 plus 6, which gives negative 1 over negative 2, which is 1 over 2. So we got our m, which is 1 over 2. Now we have a m, which is the slope, and we have 2 points. Now again, we can choose whichever point we want and try to find the equation of the line that's passing through that point, which has a slope of 1 by 2. I'm going to use the second point here. So I'll have x1 comma y1 equals negative 8 comma negative 2 as a point, and I'll plug it in into our point slope form here. So instead of y2, I'll have y, and y1 is negative 2, m is 1 over 2, x2 is going to be x, and x1 here is negative 8. So I get y plus 2 equals 1 by 2 times x plus 8. So it's y plus 2, expanding this, we get 1 by 2 x plus 4, and y equals 1 by 2 x plus 4 minus 2, y equals half of x plus 2. So we get this as our equation, and let us now verify if this is the right answer. Let me plug in the other point. Let me plug in negative 6 comma negative 1 into this equation to see if we get left hand side equals right hand side. So y here is negative 1 and x here is negative 6, right? So we can have negative 1 equals negative 3 plus 2. We end up with negative 1 equals negative 1, which is a true statement. So we have verified that this is the equation of the line which passes through both of these points and has the slope 1 over 2. All right, that is the end of this topic here, and in the next next video, I will be talking about parallel lines and perpendicular lines, and we'll do some word problems. Until then, keep practicing, and if you know somebody who's going to benefit from these videos, please feel free to share them, and I will see you in the next one.